start with the periodic table. Okay, this is unit test paper for periodic table class 10th ICSE. This is straight from Dalal textbook. Okay, so here first question, in period 2 element A is to the right of element B. Okay, mark my words, it is to the right. You have to, if you are not being able to, you're getting confused or so, please write it. Okay, write A beside B and write A to the right of B and then start thinking. That helps you to think. So if A is to the right of B, the element A would probably have a smaller or larger atomic size than B. Okay, so element A, if it is to the right of B, as you know, the trend in periodic table, in a period, the atomic size becomes smaller as we go from left to right. Okay, so A will have a smaller atomic size than that of B. Okay, so the first answer is A. The second answer, element B would probably have element B, which is to the left now. Okay, this is to be remembered. That is why I told you, please write it like that and then start. Element B would probably have lower or higher ionization potential than A. Ionization potential, according to the trend of periodic table, goes higher. Okay, increases as we go from left to right. So element B will have a lower IP than that of A. So it is lower. Element A would have lesser or higher electron affinity. As we go from left to right in a period, the electron affinity increases. So A, if it is to the right of B, then it will have a higher electron affinity than B. Nuclear charge of element B would be less, or will it be more than element A? Now nuclear charge, as the atomic number increases from left to right, nuclear charge also increases. So nuclear charge will be less for element B because B is to the left, okay, than A. If element C has a lower electronegativity and IP, it would have more. Element C, that is, they are talking about another new element here, has a low electronegativity and ionization potential. It would have more tendency. So lower electronegativity, lower ionization potential, it will have more tendency to. Now if something has low electronegativity and low ionization potential, it only means that it is more electropositive, and so it will have more tendency to lose electrons. Okay, come to question number 2. With reference to period 3 of the periodic table, state the type of bonding of the element with electronic configuration 271. Type of bonding of the element with electronic configuration 287. 287 means it needs just one more electron in the last orbit to complete its octet. Here remember one thing, you are not asked for chlorine, whether it's chlorine, whether it is sodium. Okay, they are just asking for the type of bonding of the element with electronic configuration 287. With reference to period 3. Now that is going to be the type of bonding of the element. It can be, the type of bonding can be ionic as well as covalent. Now depending on from which side you are picking up, which side of the periodic table you are picking up elements. Okay, if you are picking up elements from the left of the periodic table, and because 287 will be in the right, extreme right of the periodic table, so if you are picking the element from the left of the periodic table and trying to make it bond to 287, it will be ionic. But if the 287 element is bonding with itself, then it will be covalent. So let's see the formula of the chloride of the element with electronic configuration 287. Formula of the chloride of the element, that means it is bonding with chlorine and the element has electronic configuration 287, then what will be the formula? So the formula is going to be the formula of the chloride of the element with electronic configuration 284. Now if it is silicon with chlorine, it is going to be Si, okay, supposing the one with electronic configuration 284 is silicon, though they have not written the name, they have not asked for the name, okay, Cl and 4, because covalent bonding between silicon and chlorine, okay, to form a chloride SiCl4, okay, because each of those atoms of chlorine will take one electron from, because each of those elements of silicon will take one, because each of those elements, each of the last orbits of chlorine will be forming a single covalent bond with silicon and thus will form SiCl4, okay. The nature of the oxide of the alkaline earth metal in this period, the alkaline earth metal in this period is Na, and so the nature of the oxide is going to be basic, okay, is going to be basic. The alkaline earth metal in this period, the alkaline earth metal in this period 3 is sodium, okay. Then the number of electrons in the penultimate shell of the element with valency 1, number of electrons in the penultimate shell with valency 1. Now penultimate shell with valency 1, the number of elements will always be 8, okay. The number of elements in the penultimate means the one inside the last one, the one inside the last orbit, that they are calling as penultimate. So the number of elements in the penultimate shell is going to be 8 clearly, okay. The electronic configuration of the element whose hydroxide is a weak base, electronic configuration of the element whose hydroxide, so if the electronic configuration of the element whose hydroxide is a weak base in this period 3, in period 3 it is going to be 2 and then 8, yes, and then 3, okay, 2, 8 and 3, because it is aluminium hydroxide. Let's come to question number 3. The reference with reference to group 1A of the periodic table, fill in the, so this is group 1A, fill in the ones tables with the correct words, okay. So here we have the elements are light or heavy. The elements are light, okay, it is light. Are they metals or non-metals? Group 1A definitely metals, okay. To the left of the periodic table will always be metals. Since their atomic size elements have low melting point or atomic size is large or small. Atomic size is large because slowly as we go to the right of the periodic table, then the size becomes small. Energy binding the atoms is high or low. The energy binding the atoms is high, because these are the ones which are very strong metals, so the energy binding is high, and hence elements have high or low melting points. Elements have high melting points because the bonding between them is, that is electrostatic force of attraction, is high. Okay, whenever it forms a bonding with anything, it forms with oxygen or with halogens or whatever, it forms a bonding because they are strong metals, so they form a strong bonding, and so they have high melting and boiling points. They generally form ionic compounds, and ionic compounds also have high melting and boiling points. The melting points of the elements increases or decreases down the group. The melting point of the element increases or decreases down the group. As we go down, they become the melting point of the elements, do they increase? As we go down, they become stronger metals. Okay, they become stronger metals. As they become stronger metals, the melting point increases. Point of the elements decrease. Now why do they decrease? Okay, as we go down a group, melting point decreases in group 1a because you get larger atoms, and larger atoms means the weaker, the electrons in the outer shell is held more weakly, and so there are more number of shells as you move down, and the bonds are weaker. Therefore the bonds are weaker because the nucleus is little far away. So as we go down the group, bigger atomic number means melting point will now decrease down the group. The electropositive character increases or decreases. Does the electropositive character increase or decrease down a group? Electropositive character increases down a group. Okay, because down a group electropositive character increases. As we go higher up in a group, electronegative character increases. And elements are strong reducing agents or oxidizing agents. Now remember, the more electropositive it is, the bigger, the more reducing it is. Okay, so they are, these elements, as we go down the group, they become stronger reducing agents. The elements with electronic configuration 281 will have higher or lower electron affinity and smaller or larger atomic size than the element with electronic configuration 2-1. Okay, so they are asking basically, as we go down the group from 2 shells to 3 shells we have come, from period 2 to period 3 we have come. Okay, will the electron affinity increase for 281 or will the electron affinity decrease? Okay, so here for 281, as it becomes more electropositive in nature, so it will have lower electronegativity. Okay, lower electronegativity, because electronegativity is a property of electron affinity is a property of electronegative substances. So since it is more electropositive, lower electronegativity and larger atomic size, definitely with higher nuclear charge, it is larger atomic size, okay, than the element of electronic configuration 2-1. Okay, let's come to question number 4. In question number 4, match the elements in column X with the correct group that belong to column Y. Elements with atomic number 19. Elements with atomic number 19 is 2881. Okay, so that is, if last orbit is having 1 electron, that means it is will connect it to group 1. Okay, so elements with electronic configuration 2, that is just one shell, okay, just one orbit, then electronic configuration is 2. That can happen only for helium, that's an inert gas, so it is group 18. Elements with valency -2 is group 16. Okay, elements with valency -2 is group 16 because it's like oxygen. Element P, which loses 3 electrons to form a cation, this will be found in group 13, loses 3 electrons to form a cation, that is aluminium. Element Q in period 3, which has the highest electron affinity in period 3, highest electron affinity. Okay, please don't take the inert gases. In period 3, highest electron affinity is always the halogens. Halogens has the highest electron affinity, that is group 17. Occurrence of characteristic properties of elements that take place at definite intervals in the modern periodic table. Occurrence of characteristic properties of elements takes place at definite intervals. Occurrence of characteristic properties of elements that takes place. Give reasons for the following. Occurrence of characteristic properties of elements that takes place at definite intervals in the modern periodic table. After definite intervals of time, that is, as we go from the first group to the last group, as we go from the alkaline earth metals to the inert gases to the right, after definite, and then we repeat the same, okay, for the next set of atomic numbers with increasing atomic numbers. So after definite intervals of time, similar valence shells can happen. Okay, so as similar valence shells and similar electronic configurations happen, as the intervals of time repeat itself with increasing atomic number, okay, we don't get the same electronic configuration, but we do get similar electronic configuration, and that is why the characteristic properties of elements start repeating. Okay, properties of elements are periodic functions of their atomic numbers and not atomic weights. Properties of elements depend on their electronic configuration, okay, and which has nothing to do with atomic weights. Okay, so due to electronic configuration, the elements are periodic functions of their atomic numbers. Atomic numbers give us the electronic configuration, and since properties of any element is dependent on the number of electrons in the valence shell, so that is why properties are dependent on the periodic functions of atomic numbers and not atomic weights. Okay, so your keyword here is electronic configuration. Please put down your keywords in all the give reason questions. Okay, in the previous one it was similar valence shell was the keyword, or similar valence electron was the keyword. Atomic size of an element depends on the nuclear charge of the element. Yes, the more the nuclear charge, the more the electrons. Okay, and so the number of orbits also increase. So atomic number of an element depends on the nuclear charge. Yes, atomic size definitely, if the atomic size increases, that means the nuclear charge, that is the number of electrons, have also increased. But then there is a problem here. Just because atomic size has just because nuclear charge has increased, atomic size will not increase. Okay, if the nuclear charge is high, supposing the nuclear charge is high somewhere, okay, but the number of orbits remain the same for the same nuclear charge, there are 3 orbits only, then what happens is, due to the high nuclear charge, attraction on the last orbit is more, and when attraction on the last orbit is more, the atomic size decreases, and that is exactly what happens in our periods from left to right. The number in one period, the number of orbits is same. The number of orbits remains same in one period, but the nuclear charge keeps on increasing. That is why the last orbit tries to, is pulled little towards the nucleus. That decreases the atomic size. Okay, so atomic size of an element depends on the nuclear charge. If the number of orbits are same, then size will decrease. If the number of orbits are not same, then that size can increase. Down a group, electronegativity should increase with increase in nuclear charge, but is seen with down a group, electronegativity should increase with nuclear charge, but it is seen that electronegativity decreases. Okay, so now electronegativity decreases down a group. What they are saying is it should have increased because nuclear charge is increasing. Okay, so it should have gone higher, but it is just the opposite. Electronegativity decreases as we go down a group. The reason is increase in the radii. As we go down, nuclear charge increases, atomic radii increases, and that dominates over the increase in nuclear charge. Okay, so even if the radii is, because the radii is increasing, even if the nuclear charge is increasing, still electronegativity keeps on, because increase in radii, atomic radii dominates over increase in nuclear charge. So atomic radii has the bigger say here. If combining atoms have nearly similar electronegativities, the bond between them is covalent. Yes, correct. Between similar electronegativities, the bonding is always covalent. The reason is, if they have same electronegativities, the bonding will be covalent, because nobody wants to give their electrons. As long as nobody wants to give their electrons, donating and accepting cannot happen. And if donating and accepting cannot happen, they come to the midway process, which is sharing. Sharing means covalent. Okay, so nobody is ready to give the electrons because electronegativities are almost same, and so now what they come to a solution of sharing electrons. Sharing means covalent bonding. So when electronegativities are quite similar, covalent bondings happen. Ionic bonding cannot happen due to lack of donation and acceptance. Arrange the following elements as per guidelines in brackets. Now, in decreasing order of atomic size, we have to go from the left to right. So in decreasing order, because atomic size decreases from left to right, so it is first sodium. Okay, so it is first sodium, then comes magnesium. Okay, then comes magnesium, and then comes phosphorus, and then comes to the right end, okay, chlorine. Chlorine has the smallest size. Then Cli, lithium, fluorine and nitrogen in increasing order of electronegativity. So first, of course, increasing order, so first will be lithium. Okay, first one is lithium. Then comes, first one is lithium, then comes carbon. Okay, as we are moving to the right, then comes nitrogen, and then comes fluorine. Okay, in increasing order of IP will increase as we go from left to right. So increasing order of IP will be, first sodium. Okay, first is sodium, then comes aluminium. okay, little higher IP as we are going to the right of the period. Then comes chlorine, then comes sulfur, and then comes chlorine. Chlorine has the highest IP. Why chlorine has the highest IP? Because chlorine is will not easily let go any of its electrons. Increasing order of electron affinity, again first comes electron affinity is the least for lithium, okay. So increasing order of electron affinity is least for lithium. Then comes carbon, okay, then comes oxygen, and then comes fluorine. This is the least electron, this is the least electron. Fluorine is the highest electron affinity. Now they are asking increasing order of electron shells. Okay, this is everything in group 18. All are inert gases. Electron shells increasing order. First is helium, okay, and then comes neon. This much you will have to remember a little bit, and then comes argon. Okay, so as we go down, the number of electron shells increase. So this is the, we'll do more questions on periodic table, okay. So we'll be doing many more questions on periodic table, because I feel that periodic table, though you know the concept, it is important to understand how to answer these questions, okay. So we'll stop here today. If you have liked the video, do not forget to like, share and subscribe. Lots of more videos will be coming up of explanations of topics too, and I shall be solving lots of more questions.